Okay, let's go over this quick short review. Number 1 says find x when x equals log base 4 of 64. So remember, when we look at a log with a base, we are thinking about it as that is the base of a potential exponential, right? And if it helps you, sometimes it helps to just switch between forms because it allows us to think about it in a way we're more comfortable with. So if you want to, you can always switch forms. Remember, it's the base to the exponent equals the number. So we're saying 4 to the x power equals 64. Right? So when we read log base 4 of 64, what we're really asking is what exponent do I need to raise 4 to make it 64? And the correct answer here would be that you need to raise 4 to the third power so that it would become 64. Same idea with number 2. I'm thinking 1/2 to what power equals x, but here we actually are given the exponent and we just have to see what it would equal, right? So again, another opportunity to switch between forms where that would be helpful. So we're taking the base, we're raising it to the exponent, and we're setting it equal. So now what we're doing is 1/2 to the negative third power equals x. So all we have to do is simplify 1/2 to the negative third. So remember, when you have a negative exponent, that's that ticket to ride. So it becomes 2 to the third power, and 2 cubed is 8. So x equals 8. All right, let's look at number 3. In number 3, we are condensing and simplifying when it's possible. So the first thing here, I'm going to get rid of any coefficients of the log. So remember, if a log has a coefficient, it becomes the exponent inside that log. So this one just changes to log base 4 of x cubed. All right, now I'm going to start to combine some things that I can. I see the first 2 logs are being added. So remember, the rule is when 2 logs are added, we can condense them into one by multiplying what's inside of the log. So I'm going to condense these into 1 log base 4 of, take 21 times the x cubed. Minus, notice in parentheses we have 2 logs. Just like order of operations, we simplify what's in parentheses before we put it with everything else. So I can simplify these 2. They are being added. So again, when we condense, we multiply. It becomes log base 4 of 7x. All right, now I'm down to just 2 logs. I have the first log minus the second. When we subtract 2 logs, we can condense them into one by dividing what's inside of the log. So this becomes log base 4 of, well, this was the first one, so that's our numerator, 21x cubed, over, this is what's inside the second one, so over 7x, that's our denominator. Now, we've condensed it fully. The last thing we need to do is check to see if we can simplify. When we see if we can simplify, we're really looking at the fraction in here. Is there anything that we could reduce? And we can, because we know that, I'm going to rewrite this log base 4. We know that 21 divided by 7 is a whole number. That reduces to 3. And x cubed divided by x, think about exponent rules, is just x squared. So this reduces down even further to log base 4 of 3x squared. All right, let's do the opposite, expanding. So when we expand, the first thing I would do is looking at this part right here, right? This is what we're trying to expand. If there's a fraction, I'm going to start by breaking up that fraction. So in order to do that, we're going to take what's in the numerator and create our first log. So log base 3 of 9, the numerator, minus, I'm going to put into parentheses, the denominator. So maybe I'll highlight this here so we can tell what comes from what. And then the denominator, I'm going to write in here. So log base 3 of 2x cubed. And now we're just going to expand anything else that we can. So log base 3 of 9 can't be expanded. We're going to leave it just for now. minus log base 3 of 2 times x cubed. These are being multiplied, which we know we can expand multiplication into two separate logs that are being added to each other. So this becomes log base 3 of 2 plus log base 3 of x cubed. All right, the last thing we want to do is try to simplify anything we can. The first log, log base 3 of 9, reduces. Think about it like this. 3 to what power is 9? We know 3 squared is 9, and so we know that log base 3 of 9 is equivalent to 2. So that one can actually just be rewritten as 2. Now in parentheses, log base 3 of 2, 3 does not have an exponent that we can raise it to get to 2. So this one we can't simplify. We're just going to leave it as log base 3 of 2. Plus the next one, log base 3 of x cubed. When we are simplifying, we never leave an exponent in the log when we are expanding them. So we need to move that exponent back out front, and it becomes 3 times log base 3 of x. And there is our final expanded solution. All right. Numbers 5 through 8, we're using this information here. We're given two different logs, and we're going to use them to solve the ones we know. The first one is log base 4 of 21. When you do these problems, look at the two logs you have, look at the base, and then look at the log you're looking for. Is there a way that I could rewrite the number 21 as a combination of 4, 3, or 7? So rewriting it somehow so it's 3s, 7s, 4s, any of those multiplied, divided together. To get 21 from 3, 7, and 4, we know that 21 is just 7 times 3, right? So I can change this to log base 4 of 7 times 3, and it's still the same as before. All right, now I want to expand that. So we can expand this to log base 4 of 7 plus log base 4 of 3. Since we know when those two are being multiplied, we can add them together when we expand. Now I've got each one by itself, right? Log base 4 of 7, log base 4 of 3. Why do we do this? Because we know what each of those is equivalent to. So we can plug in the information we're given. Log base 4 of 7 is equal to 1.4037. And log base 4 of 3 is equal to 0.7925. And then we just add these two numbers together, and we get that the log base 4 of 21 is really just 2.1962. So we're just reducing down using the information we're given. How about for log base 4 of 12? How can I make 12 by multiplying or dividing 3, 4, and 7? Well, we know that 12 is 3 times 4. So I'm going to expand that. It becomes log base 4 of 3 plus log base 4 of 4. Log base 4 of 3 we know is 0.7925. Now, I told you could use 4, but we're not actually given information about 4. How come we can use it? Well, remember, log base 4 of 4, anytime you take the log of the base of that same number, it always reduces to 1, right? 4 to what power is 4? It's just 1. So this one reduces to 1. And so that way, we're able to add these two together, and we get 1.7925 as our answer. All right, looking at the next one, we already have it in just 7s and 3s. Next thing I'm going to do is expand it. So because it's division, this becomes subtraction. Log base 4 of the numerator comes first. minus log base 4 of the denominator, which is 3. We're going to plug in what we know. Log base 4 of 7 is 1.4037 minus log base 4 of 3 is 0.7925. Subtract those two, and you should get 0.6112. All right, and this last one here, I've got log base 4 of 49. How can we rewrite 49 using only 3s, 4s, or 7s? Well, we know that 49 is the same as 7 squared. Now, how does that help us? Because now we've got 7s, but we have that squareds. What do we do with the squared? Remember, it just becomes the coefficient of the log. So now we have 2 times log base 4 of 7. We know that log base 4 of 7 is 1.4037. And now we just multiply that by 2, and we get 2.8074. And there's our final solution for this one.